Welcome to our first of 3 videos on TensorFlow basics. Okay, let's get started. First, we'll show a handful of ways for creating and using tensor and variable objects. We won't have time to go over details such as the possible parameters we can use when creating and transforming tensors, but links will be provided in the additional resources slide at the end of the video. After showing the basic syntax, we'll discuss the difference between tensors and variables, which is often unclear when starting out. Finally, we'll go over the best practices for working with these objects, as well as pointing out some common pitfalls to avoid. Okay, the tensor. The tensor is the primary TensorFlow data type. As the name suggests, TensorFlow is essentially a framework for defining and running operations involving tensors, so we'll want to become as comfortable as possible working with tensor objects. The code snippet on the right shows a few of the simplest ways for directly creating a tensor. Later in the video, we'll see that it's far more common to interact with tensors via variables, but this is a good starting point for easily seeing the relationship between tensors and familiar Python objects. The simplest tensor we can create is a constant number. We've assigned x to be a constant tensor object that holds the value 3. As with nearly all objects in TensorFlow, we can obviously assign it a name, and we follow the highly recommended practice of setting that name to be the same as the symbolic name that you've chosen for your Python object. Here is x, so if we have our variable that's named, for example, bar, we want the name to be also equal to bar. We can also assign arbitrarily shaped arrays as tensors, since a tensor is essentially just a wrapper around a multidimensional array. One really handy TensorFlow function is the convert to tensor, which can convert various Python objects to a tensor. Let's see some more examples. Here we are in the Jupyter notebook associated with this video, which you can find on our GitHub repository under section 1 notebooks. And here's a snippet that shows some useful properties of tensors, shape and d-type. Here I've created a tensor with a constant value of 3, printed out. Here's what the representation looks like. First we see the tensor shape property, which is defined as a tuple of integers giving the size of the tensor along each dimension, which is the same meaning as for NumPy arrays. If our tensor just represents a single number, as is the case here, then its shape is just given by the empty tuple. Next, the d-type property gives us the tensor's data type, which here is tf.int32 since we passed in an integer. And for floats, it would be tf.float32. Before giving more complex examples, we'll need to introduce TensorFlow variables. In practice, we typically don't work with tensors, but rather with tf.variable objects. Internally, variables store a persistent tensor whose value can be changed by running operations on it. I've written a small snippet that looks very similar to the snippet we saw using constant tensors, but now with tf.variable objects, and also the tf.getVariable function, an alternative way and the recommended way of creating or getting a variable, which will be discussed in detail in later slides. In this snippet alone, we can already get a glimpse at why variables are so useful by considering what is happening when we write z equals y plus 3. Although we specified initial values for our variables, they're allowed to have those values changed as we perform operations. In fact, the distinction between tensors and variables is very much the same as the distinction between numbers and variables in regular arithmetic. Variables allow us to specify some series of operations without being tied down to specific values. Let's go back to the notebook for some more examples. Here I've shown a few more ways of creating variables. As is good practice, I've placed them inside a variable scope context named myScope. And by this I mean I have it in with tf.variables myScope. This is how you create a variable scope, and anything below it will be said to be inside that variable scope and belong to that variable scope. I've also set reuse equal to tf.autoreuse. This tells TensorFlow to create variables if they don't exist and to return them otherwise. This is just the most intuitive behavior. It's what you'd expect to happen. And for that reason, TensorFlow's documentation says that they will soon be making tf.autoreuse the default value of reuse here. But for me, which I am currently using TensorFlow version 1.7, I'm going to have to specify explicitly that I want reuse equal to tf.autoreuse. The first variable I create, I'm calling var basic, is created via the old way of creating variables, by calling the tf.variable constructor directly. We must define its initial value and optionally set params like dtype and name explicitly. Here I don't have to set dtype to tf.int32 because it will be inferred by initial value, but just showing some example parameters that you can pass in addition to the initial value. And below it we see the recommended way to create a variable by using the getVariable function. Under the hood, this checks whether there is currently any variable named varGet in the variable scope called myScope, so it searches inside the variable scope. Everything inside of a variable scope is closed off from the rest of the graph, so if there's a variable named varGet somewhere else that's not myScope, that's not going to count as the same variable. Now, we'll get more familiar with variable scopes as we go on, as it's a very core component of TensorFlow programming. So in our case, since we just started this program, there is no other variable named varGet, so this is going to create this variable for us, and we move on to, I'm going to create a variable that depends on varGet. So I'm calling it vardep creatively. Now vardep's initial value depends on the initial value of varget. So we would use the syntax shown here. For the initializer of varDep, we use varget.initializeValue, and I want it to be +1. So varDep is going to be whatever varget's initial value is, +1. We know that is going to be 7. And as a small sneak peek, I've also shown how we actually evaluate and run these operations with a TensorFlow session. That's the topic of next video. The basic idea is that we enter a session by calling with tf.session as sesh, so now everything inside of this context or with statement belongs to session, and we can use the sesh object, which is a tf.session. The typical procedure is we call session.run on the tf.global variables initializer. So all variables that we create are global variables by default, so this is going to initialize all the variables that we just created. Because in TensorFlow, you can't just use variables immediately, you have to first initialize them. We've specified the initializer, aka how to initialize a variable, but this is not the same actually initializing it. So you can view pretty much the whole part we did here as defining our graph, but we actually have to initialize the values before running things on our graph. And so to actually access the values and we say run them, call session.run on varget and vardep, and that is going to return the raw numbers 6 and 7. And so the print statement here confirms that we've evaluated Tensor's outputs to be 6 and 7. Now, that might seem like a lot just to print out some values of 6 and 7, which we defined in the first place, but soon we'll see much more complex ways of building computation graphs and executing them in sessions. This was just a nice toy example to get us familiar with variable objects. Last but not least, if we want to share variables, meaning we want to use a variable we've already created, say we want to use varget in a different part of our program, we just call the same getVariable function we used earlier when we originally created and within the same variable scope. So here I just have the exact same syntax that I used earlier to get varget, and this is how I would retrieve it later on. So when I call tf.getVariable varget here, it's not creating the varget variable, it's just getting the same one that we saw earlier. And the reason we're allowed to do that, remember, is that I've said reuse equals auto reuse. So if you've already seen this value varget, this variable varget, just give it back to me. And again, just to emphasize, I cannot just say, for example, tf.getVariable varget, close parentheses there. I have to specify the entire parameters that I passed in initially, because if I set a different d-type, for example, that's technically a different variable, and TensorFlow will get mad at you for trying to access a different variable with the same name that one already exists. So bottom line, just do the exact same syntax you used for creating the variable in the first place. We've seen variables being created with both tf.variable and tf.getVariable. So what's the difference? Well, first, I want to emphasize that when in doubt, choose getVariable. In the early days of TensorFlow, we only had tf.variable, and getVariable was introduced as the modern way to both create and access variables. One reason it was introduced was due to the concept of variable sharing, which was much more confusing in the earlier days of TensorFlow. And the modern way of sharing variables is just by using getVariable and variable scopes, as we saw in the Jupyter notebook. Another convenient reason to prefer getVariable is that it doesn't require us to specify an initial value. Instead, it has the optional initializer parameter, and we can also pass in our own preferred initializer instead of using the default. We'll revisit the benefits of getVariable and variable scopes throughout the course, as its usefulness will become more clear as we work through more complicated tasks. As always, make sure to read through the links here for an in-depth look at the topics covered today. Next up, in TensorFlow Basics Part 2, we'll learn about the two core concepts underlying the TensorFlow framework, graphs and sessions.